Shane, what's up, man?
Hey, thank you for having me. It's
Anytime, anytime.
beautiful.
Yeah, where you dialing in from?
I'm from a little place called Paikokariki, which is in New Zealand. So, for the audience out there that can find a map that has New Zealand on it, we're at the bottom arse end of the world. There's two islands, top island called North Island, funny enough, and a bottom island called South Island. I'm at the bottom of the North Island on the left, on the coast there.
Hmm. That is a very New Zealand sounding town as well.
Yeah, yeah. We have some cool names. Yeah, yeah,
Yeah, yeah. I
yeah.
can't pronounce any of them. They just sound like uh, but they sound cool. So,
Yeah, it's the one that's really interesting is the ones that start with WH because they're all
hmm.
we get people coming to visit and so we have a town called Whakatane because the WH is always said with an F. Yeah, so it's kind of cool.
Oh, that's hilarious. Huh. Guess I'll have to make it there just so I can go on a tour of strangely named towns. So, uh, that's awesome, man. Yeah, and yeah, you are kind of, I guess, as they say, at the ass end of the world too, which I think gives you a unique perspective, right? You're not in the thick of things like as we are in America. So I think it gives you maybe a different vantage point to view the world, right?
Yeah, I think it's we have some benefits and we have some downsides. So one of the
Mm,
benefits is we typically we get to pick and choose the waves or the the buzz washing that happens that turns up in New Zealand because we adopt patterns from the US as much as we do as Europe. The second thing I think that's to our benefit is we're a really small country, and because of that, we have to be quite innovative. So we'll tend to pick and choose and test things probably a lot more than we see overseas. Downside being is just our critical mass.
mm.
For me to go to a conference and actually talk to people, it's typically somewhere between 24 hours and 36 hours of traveling. So that's a little bit onerous, right? So we don't tend to meet and greet people as much as the rest of the world. However, COVID was a blessing for us in terms of everybody going remote, and remote conferences has been a
Mm.
big change to me and way of interacting with people like yourself.
Yeah, it's super cool. I don't think we would have met if it weren't for Slack and social media and COVID. So, but thank goodness for that. So, but it's interesting too because I see you on the data quality camp Slack often. We I would say chat. We chime in on a lot of the same threads. I think have a lot of similar viewpoints, which is pretty cool and also kind of echo chambery, but it is what it is. So that's what happens when you're super cool, I guess. But yeah, one thing I think that we wanted to talk about too is data modeling, right? I mean, that's kind of the topic du jour. Um, but I know you have like a lot of strong thoughts on this. So
Yeah,
what are
so I've been in the data domain for just over 30 years now, right? And I can kind of break my career up into a bunch of decades. And I'm not
mm,
technical, right? The way I kind of talk about it is, I can't code, won't code, don't code. And data modeling's always been one of those things that's annoyed me. And
mm,
it annoyed me because it became a dark art, right? Whenever we were doing a project back in my consulting days, we sometimes it just worked the modeling process and it was awesome, and sometimes it was an epic failure. Sometimes it was done quickly, sometimes it was done slowly, and it seemed like there was this priesthood of data modelers that would go and sit on their own in a dark room for 6 months with a whiteboard and come out with this enterprise canonical model. And even that word canonical, right? I mean, how unfriendly is that for the whole world? We have a canonical
mm-hmm,
model. And so I spent quite a bit of my career focusing on actually how do we make, what patterns are out there to make data modeling
mm-hmm,
accessible to people who aren't data modelers. And so that's always been one of my focuses is that idea of how do you take something that's complex and then how do you help people do it, but do it with rigor, right? Do it with patterns. So, I tend to get opinionated every now and again. So this whole idea of an analytics engineer, right, where we're moving to decentralization and self-service, which is great, right? That's what we want is more people to be able to do the work. But we've gone to the Wild West again, right? Which is basically just go write some code. And we know what happens, right? We
Mm.
know in the first 6 months it's fine, right? You just write some code, you're fast, you're agile. 2 years later, you've got 3,000 blobs of code and chaos reigns. And as part of that, I've become really, really fixated with language. So
Mm.
when DBT talks about a model, which is effectively just a blob of code, that actually makes me quite angry, right? Because we're degrading the practice that is modeling, and modeling is important. So it's about balance for me. It's about not spending 6 months to a year of one person building this enterprise canonical model that nobody will ever implement, but it's also not about 5 people hacking code with no thought for the design of that data up front. And so balance is hard, but balance is important.
It's super hard, yeah. And I've been writing a lot about that too. Sort of the spectrum of formal and strict versus relaxed, and fast maybe, but I could also make an argument that if you're formal and strict and you ingrain those patterns, you actually move faster at a certain point too. If you can get over the initial hump of, like you say, the canonical model and all the ceremony that goes in behind that kind of stuff, I think that there's definitely a lot of trade-offs for sure. So.
Yeah, and I'd be interested in your view because often we see a data model described as thing is a thing of a thing of a thing, right? Which is the most
Mm.
flexible data model in the world, right? You can actually put any data into those 4 things. But to understand it as a business user, it's a nightmare. Even as a developer or an engineer, right? To understand the relationship between this typing of things and then subtyping of thing is incredibly complex, right? So then we're saying, well, as a human, you have to have this massive amount of cognition to be able to look at that pattern and then bring it back into a business pattern and describe it. So yeah, I mean, I'll be really interested, when you publish, to see how you describe formal versus informal, right? Because that's a really interesting categorization for modeling.
Yeah, I mean, I'm kind of looking at data modeling right now as a way of just organizing and standardizing data to facilitate, useful and believable information for, both humans and machines, right? Because it's not just humans that are using the outputs of these models anymore; it's also machines. And so, but the way I'm kind of describing it too, though, it's supposed to be cross sectional, so it's not just for analytics; it's also for software engineers and machine learning engineers and so forth. So when you try and think of a model from that perspective too, we can talk about this in a bit, but you definitely want to separate that kind of the higher level concerns of the conceptual and logical modeling versus the almost infinitude of physical modeling now, because it used to be that modeling at a physical layer was just for databases, but I mean data scientists, I mean, they might be using a notebook, for example, and they might be hacking on files, they might be hacking on this, that, or the other thing, or a machine learning model may be made from text right now, right? So if you're using generative AI and transformers, it's like, well, that's not really a database. So like, what is it? But the data has to still be useful and clean. So, and the output of that is a model too. So it's like, it's a lot more complicated, I think, than it used to be too.
Yeah, I think the use cases are far more complicated. And
Mm-hmm.
before we used to ignore them, right? We used to think about, the modeling we care about is a dimensional model, a star schema in a warehouse because we want to hook up MicroStrategy, right? And in that case,
Yeah.
we'd do a Snowflake, right? Because MicroStrategy prefers Snowflake schemas over star schemas. So, for me, it's really interesting around that physical modeling because in the past, it was always based around constraints. We would model based on the thing that's going to consume it, right? Like I said,
Yeah.
MicroStrategy would do snowflakes. Power BI, there's this whole argument around direct query versus indirect query, right? Do we cache it in Power BI or do not? And that Power BI only likes dimensional models. And I haven't tested it, right? I think it's bullshit, but I actually haven't tested it, so I can't say whether I'm right or wrong. But we tended to model around those constraints. We would have on-premise databases that were really expensive, the Oracles of the world. So we would model in a way that reduced the amount of data we stored because otherwise we'd blow all the CPU. A lot of those constraints have gone. So what we now need to be modeling around is around usage. And your example of a ML engineer is really interesting. Because if we think about, what do they typically want? They typically want a big, wide, denormalized table with a bunch of columns that are feature
Yep.
flags. Yeah, ones or zeros. Um, And in the past, it used to be, well, here's our star schema. You go and then create yet another model on top of that, which gave you that format that you wanted. I think we're at the stage now where actually from a physical modeling point of view, we can start to be lazy, right? Because we have the benefit of scale at a cost that we haven't had before. So we should be able to deploy, a star schema, a data vault model, an activity schema, and a feature store as physical representations of the same data with one click, right? That's where we should be. And then the questions, it comes back to not the physical structure of the data,
Mm-hmm.
but the language, right? What language do you speak? If you're a machine learning engineer, I speak a language of wide tables with lots of rows of raw data that's got feature flags. Yeah. And so for me, data modeling is actually going to become more and more about shared language than the technical
Mm.
implementation that we focused on for the last couple of generations.
That's a really interesting point about the shared language. I hadn't thought about that actually. I like that. Yeah, because you're absolutely right. There's just too many. If you kind of zoom out, and this is a thought experiment I don't think a lot of people have really done. I think maybe you have, but thinking about data sort of cross-sectionally across the data lifecycle, really, and the different ways that it's modeled. But the shared language is really the only glue that holds all that together at the end of the day, right? So if you have a notion of a customer at the at an application layer and then at a report and at a machine learning model, I mean, hopefully these are the same notions of a, say, a customer, for example, that you're trying to do something with, whether it's report on it or predict on it, or you know, um, they're using the app, for example, right? I don't know, but
Yeah.
it's
Yeah.
fascinating.
So in 33 years, I've never seen a customer in data, right? I've always seen the word in front of it,
Mm.
marketing customer, risk customer,
Yeah, yeah, yeah.
finance
Yep,
customer, active customer, inactive customer, active marketing customer.
yep.
There's always a word in front of it, right? Because customer is too broad a definition. And then what I always encourage people to
True.
do is then pick one of those bigger terms, right? Active marketing customer, and then say the alias for that is customer. We all agree that that definition is actually the definition we'll use whenever we use the word customer on its own. And for me, that again, it comes back to that language, right? If you can't, if your language is not clear, if it's just this big bucket of customer,
Right.
what happens if you have a supplier that buys off you? Are they a supplier and a customer? Are they a customer? Right? Are they some quasi customer supplier hybrid? So that shared language is really, really important. And without that, how do you model, right? How do you put a conceptual or a visual representation or even a physical representation of that data when you're using different language at the beginning?
Well, it's really hard, especially when you take into account that data is now starting to be shared not just within an organization but across different organizations. And when you have the name, I don't know, customer, like what do you mean by that exactly, right? Especially in between organizations, that's it's hard enough to using the word customer very intentionally for the reasons you described, where there's just a million different ways of describing it, and then you start looking at it across a lens of several different organizations, and what do we mean by that, or what do we mean by sales? I don't know, right? So it becomes a very interesting exercise, but modeling is just one of these things where it sort of happens if you're not intentional about it, and it happens if you're intentional about it. So, what kind of model do you want, right? But that shared vocabulary is definitely a very, very, very strong notion for sure. So,
Yeah, and in the data world, we love three-letter acronyms, right? And so SCD type two. Wow. Now
yeah,
there's a language that is designed to make it a priesthood, right? Uh, we'll if we work in data, we typically know what it is. It would be interesting, right? It'd be really interesting to do a survey to see whether the new wave of analytics engineers actually understand what SCD2 is and why it was there.
mm,
And I still question: do we need it anymore? It was a technique for
right.
star schemas, right? It was about breaking change records out from the fact because joining all those tables together in one go was so big and expensive that the databases at the time couldn't handle it, right? So we compartmentalized. We said, well, if we break things out into dimensions, then actually we can subquery, right? We can say these three things: customer, order, and product. At a point in time had a relationship. That's the fact, and therefore we don't need to worry about location or store or channel at that moment for that query, and therefore the query was smaller, ran faster on our databases. That's not true anymore. We've got a customer where we have a table that's just hitting 300 million rows, right? It's completely denormalized. It's got 300 columns. It's got a bunch of text in there. But because it's based on a columnar database, whenever you are hitting it, you're only hitting 5 to 10 columns, and the database takes care of
Right.
that complexity for me. I don't have to worry about that physical modeling anymore as much as I used to, right? I still have to care, especially when you get the bill. So, yeah, I think, a lot of our modeling techniques have been designed and based around constraints that we had 20, 30 years ago. And I'm not sure we've iterated them, which is interesting.
Yeah, I mean, back to your bet of whether an analytics engineer these days would understand the different types of SCDs. I would wager that they are not familiar with them, and this is based upon I think talking to analytics engineers and seeing how they're learning about data these days. As well as anecdotal stuff too. Well, it's all anecdotal. I haven't done a survey yet, but some friends of mine had given a talk at Coalesce, the DBT conference on data modeling, and for other friends of mine were standing in the back of that conference actually, like, and watching people type in like what is dimensional modeling into their Google bar, and so but I mean, think about that for a second. That this is DBT, wonderful product, great company, and so forth, and I think they've done a remarkable job, getting the mind share with what they're doing. But this is also a data transformation for analytics, right? So historically, that would be Kimball, or some approach like that, and now it's like that's kind of a foreign concept, perhaps. Could be wrong, but don't think so.
Yeah, I think it's also regional as well. So yeah, in
Mm,
Europe we see a lot more data bulk. So I mean,
yeah, it's true.
I was around in the Kimball versus Inman wars, right? And people go,
Yeah.
and it was interesting. People say that Inman and Kimball didn't actually have a war amongst themselves, and that was probably true. Didn't know them at the time, and not sure. But actually, for us, at least in New Zealand and the rest, and I think the rest of the world, we were warring. Right, yeah, there was Team Kimball and there was Team Inman, and we were scrapping it out on every project. Right,
Mm,
it was like, what's our architectural design for data? Um, and then we've seen that to a degree between dimensional modeling and data vault, right? And what's
yeah.
really interesting is it becomes a religion, it becomes a passion. And I'm Team Data Vault, and even within Data Vault, right? There's actually two teams within Data Vault, right? Team
Hmm.
Dan, Team Hans, right? And I'm Team Hans, and so we get this passion around these things that we've got good at doing. And then rather than trying encouraging people, we try and force them. We become
Mm,
derogatory, right? Like, you idiot. What are you doing when you're not doing SED2 type 2 on your DIMS? What, you mean you don't
right.
even know what that 3-letter acronym is? And so for me, I think the failure of adoption of data modeling, or what I call data design in the market right now, is not the fault of people like DBT who haven't encouraged it. It's actually the fault of us as data modelers,
Mm,
not being good at teaching other people why the art and craft that we do is valuable. And so, if you watch what the vitriol that tends to happen on social media, we tend to go quickly into, you're an idiot, you don't know what you're doing. And
right.
I did a presentation at a virtual conference last year, and my presentation was, how do we help analysts data model? Right, that was the focus of it. About 3 presentations in, somebody else basically did another presentation, which I would class. How would I describe it? Being polite. Here's 10 examples of 101 mistakes other idiots have had when they're data modeling, so they shouldn't. And the one that got me was the presenter brought up a slide, and it had a person in a bar playing a guitar. And he said, everybody can play a guitar, but they can't play it well. So if you're not, a trained classical guitarist, you shouldn't play guitar. And for
Interesting.
me, that was like just the complete opposite of what I said in my one, which is, people can model, and there are a whole lot of things need to learn, and it is risky. And there's times where you want an expert to come in and deal with a level of complexity that somebody who's not really, really experienced can't. But actually, we should teach everybody to model in 90% of the cases. And
Mhm.
so for me, I think that's part of the problem, right? Is that there's a whole lot of complexity in there, and maybe we'll come back to this idea of the data value stream, I call it. But the areas in the way we move data and the different modeling techniques, and why there are
Mhm.
different ones, which introduces the complexity. But I think as a data modeling community, we need to look at ourselves about the way we engage and make people
Yeah.
feel, and then ask that question, why would somebody want to talk to us when we basically don't help them understand what we do? Um,
I
anyway,
completely agree with that. I mean, that's one of the reasons I'm working on the book I am. It's more kind of taking the approach of I don't know, Bruce Lee with the Jeet Kune Do or something like that, where it's very multidisciplinary, right? As you say, value stream, I think is a really good example of that. Just kind of there's different techniques. I'm not here to tell you what to do. I think you're capable of making an evaluation of your trade offs based on your situation. So, but just at least be aware these are techniques that you could use if you wanted. That's the approach I take. I do agree with you and your assessment that there are certain factions in the data modeling world that are very dogmatic and I would say borderline toxic in terms of how they treat people. I see a lot of these same discussions you're talking about online, and I mean, frankly, it feels um, it's kind of like, and then you wonder why nobody wants to talk to you about data modeling, right? Because why would anyone want to even have like a simple discussion with you about anything if all you're going to do is just criticize them and put them down and call them a loser, right? That's nobody wants to deal with that.
yeah, and some of those people I'd call friends. And
Mm.
the way I liken it is they're not doing it to be assholes. Most of them, right? It's not done on purpose. I remember back in the days when we had on-premise databases, we always used to have a DBA, database administrator, right? There was always somebody that tuned the Oracle or SQL Server and or Infomix database, and they were typically, and sorry to all the DBAs out there who are lovely, but the ones I dealt with were defined as the word toxic. Because they were really experts and they were always busy and they were always grumpy. And you go to them and you go, one of the team, because again, can't code, don't code, won't code. One of the team I was working with, their queries are running slow. They'd go to the DBA and they'd go, my query is running slow, right? So basically, open ended question, I have a problem. And typically the answer they get back is, well, compared to what? And it was like, well, how's that help? And then it was like, well, I ran it 3 times last week because you learnt, right? And we got a 1 minute response time those 3 times, and now I'm getting 5 minutes. So there's obviously something wrong with the database. So now we set up this friction, right? It's your database, and then the
Hmm.
answer tended to come back was, well, no, it's not my database, it's your code. And then rather than go into the
Oh,
database and tune it, the DBA, because most DBAs came from a development background, right? That was their path. They was great developers, and then they became really great DBAs. They then go into the code and rewrite the developer's code so it ran faster. And that, and again, it's not because they were assholes on purpose. It was just the way they worked, right? They were detailed people. They wanted to solve the problem. And for me, that's what I see in the data modeling community.
mm.
People are trying to be helpful. It's just the way that they engage is kind of out of alignment, I think, of the way that people who want to engage on the other side want to be engaged with, if that makes sense.
Yeah, makes a lot of sense. Yeah, and I mean, I'm looking at one of my books right now. It was at 50 Years of Relational Databases, another database writings by Chris Date. I mean, smart dude, good book. Every page is also full of vitriol about like, if you're not following the relational model, then you know I mean, just it's you're just not a great person. It seems like every page I read in the book, I feel that way, and it's a very interesting take. But
But
I
things have
personally
moved
haven't
on,
ever
right?
seen. What's that?
Oh, you go.
No, I mean, I haven't seen any business, for example, fail because they didn't, adhere to very strict relational modeling practices. But if you read through the book, then it's kind of like, well, yeah, if you're not doing this, then you're building your entire infrastructure on a shaky foundations. I'm like, well, I don't know. I don't think I've ever seen a business fail because of that. I think I've seen it fail because of really poor business decisions. But you'll read what you want into the world, right? So the lens that
Yeah.
you have is the lens you have. So
Yeah, I think for me, I think there's a bunch of core foundational patterns, and you should apply them when you
Hmm.
can because they just make
Yeah, of
sense.
course.
And
Yeah.
when you decide not to, it needs to be a conscious decision, and you need to be cognizant of the fact you're cheating. So we've had this breather of NoSQL databases turn up, right, and it's now the cool thing
Hmm.
to go and build an application with. And there's massive benefits from an agility and speed to market of being able to do that, but you don't get primary keys. So that's fine, right? You get speed and agility to build that application. That's great. But when you try and use that data, you're just moving the cost somewhere else, right? So now somebody's got to look
Hmm.
at the data and go, hey, where's my primary key? Because that used to be a great hint to say, this thing's a thing. These two things are related. So you move that work a little bit. And so I agree with you that I can't think of an example where, apart from data breaches, where I can say that organization failed because of their data modeling. But I think I could point to lots of organizations where their costs and their speed to market uh, were way higher than they should have been because of bad data modeling practices. Or
That
trade,
very
let's
well
put it a
could be the
different way.
case.
Yeah, trade offs made without a conscious decision, you're making the trade off. Yeah, that's probably a better way
Hmm.
of putting it.
Yeah.
So, yeah, but, if we go back to that layered problem, we have a habit in the data world right now, and we have for 30 years, and we haven't changed it, that as we move data and add value to it, right into that value stream, we tend to want to adopt a different data model technique at each layer. And maybe we have to, right? I still haven't thought about it enough to go, do we have to? Because there is not one data model approach to rule them all. Um, but we don't tend to have reuse as much as we move across the layers for some reason.
Right.
And if we think about application development, it took me ages to figure out what the hell this thing my UX designer kept talking about, which was a design system, right? Oh, what the hell is it? And really, the way I boiled it down to now, it's reuse, right? When we do a UX piece of design in our app, we then, that design is reused time and time again where we can, where it makes sense, right? Because it reduces our cost, it reduces the cognition of the user to understand what's on the screen. In the data world, we don't tend to do that, right? We don't tend to design something and then reuse it in many different places. It tends to be a,
Right.
a one and done for some reason.
Yeah. Whereas like front end's kind of all about reusability, right? Because there's just different components. I mean, if you've ever written a React app, for example, it's like that's like literally the notion of it is reusable components, and I think it's just a matter of like having empathy or at least understanding sort of what people on the left and the right are doing. Say you being in data, for example, right? So upstream with application developers, like how are they using data? They have a very different use case for it than say the analytics person or the ML person. My take on this is that there's just depending where you are in the life cycle or the value chain, it's just you're probably going to have to think about at least a physical implementation for that use case there, and that's about it. Really, there's not a one size. It's not like you're going to tell them, oh yeah, you need to put everything into a dimensional model for your front end. Like that would just be they would stare at you very strangely and then walk away, or at least I would. It's like you don't know what you're doing. I'll see you. So,
Is,
but
is
same
it,
thing, right? So,
yeah, isn't that the definition of data mesh? Take the complexity of data, take the complexity of data modeling the consumption of the data and push it back on that poor software engineer who's kind of busy anyway, right?
yeah, I mean, we can get into that too. I actually had to give a talk a couple months ago at a Starburst conference about it was a debate on whether data mesh would do away with data engineering, and I had to take the side that it actually would, which it was partly trolly for sure, but and I actually Jim a really good friend of mine, and so I asked her, why do you think this, right? Like, what do you because it's in her book. I think she comes from a software background, so she has a different perspective than she's not a data person, at least like you and I are. And so I think it was interesting getting her perspective, where she feels that at the end of the day, maybe it is all software all the way down, and then
So
which
I
is
actually
it's
I agreed with that,
interesting.
right? Yeah, I agreed with that when she first wrote when she first started writing. I was in
Yeah.
100%. I didn't think we could achieve it, but I thought it was a great vision. What I've seen is a massive softening of that stance. So
Interesting.
for me, it's not about taking a data engineer or a data modeler and moving them as a separate role back into that team. It's about taking those skills that we have as data modelers
Yeah.
and enabling the software engineer to do the work.
Bingo.
And because we know they're so busy, we can't teach them the skill and expect them to do it because they just don't have time and they don't have the interest. What we need is I still think there's this idea of, as we do in software development, a set of libraries that take care of that complexity for us. And I think that's when data mesh decentralization back to the software team will become real. And in theory, it's what we should do, right? I mean, effectively, they're creating data for the organization. Why don't they just finish the job? Why do we have to have another whole team that does the second half of the job? But the reason is because actually the business prioritizes getting that software out the door fast. And the argument I always use is let's go through this scenario. Software development team have got a new feature, right? It's the new cash cow feature that's going to up the revenue of their company. And their company's struggling, right? So they need this new feature to survive. So the software engineering team, they're rocking it, right? They've done this development. It's taken a couple of weeks and they're ready to push that feature into production, right? Yeah, and they go to the product owner. Hey, I've got the feature done. We're all good, ready to go to production. Just need another 2 weeks to do the dimensional model on top of it so it's usable for the rest of the organization. Now, the product owner is going to go, screw that, push it, right? Because I want that business value and I'll wear that technical debt. I'll wear that cost later because they don't actually wear it themselves, right? That's the problem. Unless we automate it, and I don't know how we do that, then we're just putting more load, cognition, and effort on the software developers, and the business will make the trade-off decision they always make, which is, I have to get value. I'll wear some risk and cost in doing it.
That's really interesting. I have you thought of any ways to incentivize the business to take data more into account at the software level?
I've spent many years trying many different techniques. I've used carrots. I've used taxes. I did. So I spend a lot of my time now, apart from our startup, coaching data and analytics teams on agile and product practices. This is how we blend them together. So we've done things like technical debt registers. We've done a whole lot of stuff. We did one where we kind of started, but we didn't finish it, which I was really interested in, was if we treat data as an asset. And what I mean by that is we actually put it on the balance sheet and we actually depreciate it. And that depreciation goes back into the data teams to actually fund them to do the work. Would that change the way the organization behaves? And Doug Laney's done a lot of work around that idea of monetizing data internally for the benefit of the organization. But, in my experience, it doesn't matter what you do. For some reason, business owners make a trade-off decision and data for consumption internally comes last. However, I've never worked in a FAANG company, the big Facebooks, Alphabets and Apples of the world. And, they seem to have data as a core of their organization. So I do a podcast with a guy out of Australia, and we have, kind of product experts and agile experts come on. And, what's really interesting is I've started over the last 78 episodes, there's a bunch of themes that have come through, right? Because I kind of sit back and I'm looking for patterns. And one of the ones that's really interesting that's been described a lot is that organizations started after 2000, 2010 are inherently agile by default, right? They don't do Scrum. They just work in an agile way, right? Their growth mindset. And, once before that, they're hierarchical, right? They have organizational structures and Conway's law and all that kind of stuff. And so for me, I can almost infer, and it's an inference, right? I'm guessing here, that the post 2000, 2010 companies are also data driven. It's just what they do, right? Every decision they make is typically made based on data. Everybody before that is made on hierarchy, opinion, the hippo in the room. And so I think maybe that's where the market's lying, right? Is we're trying to change these behemoth organizations, we're trying to change the culture, and we won't, right? I was talking to somebody the other day and they said, big corporates are trying to implement data mesh. And it's like, well, they're never going to, right? You need a green fields environment to at least get completely decentralized on day one to work. We'll see, right? Can we turn those big behemoth ships around? I haven't managed to yet. I've done small changes, right? Every now and again, the rudder knocks them one step left, and we do some good practices, but it's hard.
It is hard, yeah. And I know some people that are saying they've done data mesh at larger companies. But the buy-in, it seemed like was a really difficult part, right? And then, um, and the way they accomplished data mesh, it seems like a lot of it was data sharing type stuff. So it's not exactly like, I would say, the purest form of mesh, at least as it's described in the book. But it's baby steps to get there, I guess. I don't know if we'll ever hit the ideal of true data meshes. Shamak describes it. I mean, I hope her company is really successful in making it happen. Like I said, she's a good friend of mine, and I'm rooting for her. So TBD, I guess. It's interesting because you'd almost think that it would be the same revolution that the microservices revolution, and how that happened. But I think what you're hitting on is that data is just that much harder, and that's the crux. So
Yeah, and why? That's the universal question I've yet to answer. The best I've got so far is the data team that are working with the data are not in control of the data, and I liken it to because I'm really upset on Data Kitchen and Chris, because I love the whole analogy of recipes and food with data, right? And then he kind of went and gone down the whole Data Kitchen route. So it's like, you got there first, you bugger. So but I keep going back to it because it just resonates with me. And so if you think about a data team, what's happening, right? We've got a bunch of really talented chefs in a kitchen, right? And they're really experienced at making awesome meals. And we've got a bunch of customers out the front of the shop that want those meals, right? They want their data. Their data starved, right? And what happens is the ingredients that we need get shipped to us and put in our storeroom, right? They're on the loading dock, and we go out there and half of it's rotten. I got, I'm going to go make this beautiful tomato chorizo pasta. Oh, yeah. And I go out there and my tomatoes are rotten. What am I going to do about it? Right? How do I make a meal out of that? And that's the data problem is, when you're a software engineer, you're in control of the way that data is captured. And I think one of the changes that the whole DevOps thing and why it was so successful is we enabled the software engineer to be in charge of their own kitchen equipment. And so therefore the thing that was out of their control at the time, which is, the servers and that kind of stuff, we containerized it, we microserviced it, we gave them the ability to do it themselves. And that removed both the reliance on other people, so their time to market was much faster, but it also allowed them to bake in good quality. From a data point of view, we're still stuck with somebody shipping us data, even if we go collect it ourselves, right? But they're shipping us data that's crap. And yet our customers want a beautiful meal. And that's why we have data teams, and that's why it's so hard. And then just the complexity of the rottenness of that data, right? It's hidden, Oh, look, the data looks all good, but actually when you get the context, I now have paikokariki in the South Island of New Zealand, which is just wrong. So rather than a rotten tomato, what I've got is a little bug that's sitting right in the core, and it's not until I've chopped that puppy open I was going, you buggers.
That's an interesting take. I haven't actually thought about that. The lack of control over the outcome, right? But it's definitely true. I mean, you've worked as a data person, I have, and I can't count how too many times when I've felt like I was in control of the data, right? You're on the receiving end of it most of the time, and the thing is, you're working in a kitchen too, or you're working at a restaurant where the customers, their taste change. They might want pizza, and they might want chicken wings or something. And well, I don't know if you serve both. Maybe you do. You know,
Yeah, well,
I don't know. So,
domain-driven
and
teams, right?
they change their request every second. It's like, well, actually, I want Chinese food right now. Actually,
Yeah.
so you have that. So
But we're getting there. So the idea of data domains, right? The idea of having teams that are bound by domains is
yeah,
effectively solving that. I remember I was
yep.
in Dallas pre-COVID, and I went to barbecue over there, and oh my god, I loved it, right? But we were in
Good
Vegas,
food.
and we had one of the most amazing Chinese meals I've ever had in Vegas, which I typically always say is the worst food in the world. So this idea of domains, right? I know when I go to a Chinese restaurant, I want Chinese. I know when I go to a barbecue, I'm going to have barbecue. There's a very clear indication of what you're going to get. That's what data
Yep.
domains give us. I think agile ways of working give us the ability to change. We should no longer do 6 months requirements up front, because we know we're investing in a recipe that somebody might not eat, right? Or they might go too much paprika. Well, bloody hell, I've spent 6 months doing that recipe.
Right.
So we get some techniques from there. I'm a great fan of Lawrence Cole's work around Beam. I use it all the time for the last 10 years. So we have ways of doing small requirements work up front in a language that business users understand. We can describe the difference between chicken and beef and, get clarity, or vegan and not vegan, right? It comes from an animal. It doesn't. When we kind of manufacture animal protein from DNA, which we're doing now, is going to be a really interesting conversation. However, before we get to that complexity, so if we look at the front end, there's actually lots of patterns out there now we can adopt. And then we look at the friction. So we can take Lawrence's beam methodology or pattern, and I can convert that to a dimensional model or a data vault model with no effort, right? Because it's just the language that's used matches the language of facts and DIMS or hubs,
Right.
links, and sats. And then we look at the quality problem, and we look at the stuff that Chad's doing around data contracts. So what does a restaurant do to stop the problem of rotten tomatoes, right? They have an agreement that they're going to get good quality produce from the supplier, and then they have somebody sitting there going, "Those tomatoes suck. Take them back."
Yeah.
So that idea of a data contract, right? And not just contract of schema, but contract of frequency and freshness and the context of the data, if that makes sense. Again, we're starting to get those techniques, right? We're starting to get those patterns, but nothing in the data modeling space, really. There's no
Well,
innovation or iteration happening. I mean, activity schema, I think, was an attempt,
it was
and
an
I'm still,
attempt, but it's an interesting one too because I feel like a lot of the onus is going to be on software engineers. I mean, the book I'm writing is actually geared more towards software engineers. It's not for data people per se, because if you want to address the root cause of a lot of these issues, you're going to have to start at the source. And I think it's at least making engineers aware, of these. Again, no sense in reinventing the wheel. Relational modeling works fine if you use it. Understanding how to properly use a document database and model data, and that works fine if you know how to use it. Again, it's just what I see with software engineers, and I interact with many, is that um, they do what they can to hit their sprint, right? So, and in a lot of cases, they're coding in maybe environments where there's an ORM, an object relational mapper too. So I'm not sure if you ever used one, but it is astoundingly easy to introduce lots of fields into your database, lots of duplication or more, at the drop of a hat. I need to add a field in so this form can work. Oh, I'll just do that. And the downstream effects of this is, well, it's kind of what you see right now. So my take is that, how you attack the data modeling thing upstream is simply by working with software engineers to at least reintroduce them to a lot of these practices, and and make them aware of the trade-offs, and make them understand too that the feedback loop between what they're doing and data coming back into the app. I mean, that's becoming more of a real thing too. And it's just you can choose to code in a silo, but there will be impacts to you, maybe not directly, but at least immediately, but there will be. So as every
yeah,
enterprise becomes more data driven. So
yeah, yeah. I mean, yeah, it'd be interesting whether we actually get an automated semantic layer on their stuff so that both sides
that's
can
where I
actually
always
see.
felt the semantic layer should have
Yeah,
started was
yeah.
at the application end. Dealing with I mean, I'm a process junkie too. So I mean, if I value stream map out like where all the waste occurs, uh, where it starts, like you want to address the root cause. I completely agree. The semantic layer is, I think, in the most ass backwards place possible. To be frank,
Oh,
it
look,
does its job for our reports, but I mean,
yeah,
it doesn't solve the problem.
if we take that comment you just said, right, key takeaway, is when I go and work with a new data and analytics team, one of the first things I get them to do is actually describe their value stream. Who does what, right?
Mm,
Where's the data flow? What tasks are done? Who does that work? And we visualize it, right? We do nodes and links on a screen. It's a graph. And then we figure out where the wastage is, where the constraints are, where the problems are.
yeah,
And you'd be amazed how many teams don't understand their flow of work. They don't
interesting.
think of it as a factory. They don't understand. If you just say to them, you're a factory, every time a piece of data moves and a person touches it, it's a station in a factory, right? Map it out. Go read the Phoenix project. Map it out. Where's the wastage?
Yeah.
Where's the problems? Optimize it. You make 3 changes and you'll make yourself far more efficient in a
Oh yeah.
week. because you know where it is, you just haven't visualized and agreed you're going to change it. So yeah, it's some of the simple techniques are there. That one. It's about that. Yeah, again, come back to your point. The software engineers are incented to make changes as fast as possible to get business value, and their tools are now really, really effective at that. But they don't understand the downstream impact that the other team has. You
Bingo.
know, an example is a customer of ours. Building out their own app. They're a startup, NoSQL database, all good. They come back to us and they give us a combination of snapshot files, data. So they push the data to us, right? So they give us some snapshots and they give us some change data. And one day they came back and they go, the numbers are wrong, right? The thing as a data person you always love to hear. Yeah, because you go straight into that DBA mode compared to what? So it's like, okay, what describe the problem? Okay, we have a bunch of customers in the dashboards that aren't in our application. All right, excellent. And so we go, but you're not sending us change deletes, right? You're sending us snapshots. So we don't know that customers disappeared. And they're like, so if we just send you the deleted records when we delete them, then it'll be right. And it's like, yeah, that's all we need. But they didn't think about it that way because they're not data people.
Why would they?
Why would they? Yeah, it's just like what's gone from the app, like problem solved, right? Another one, the one that really, really gets you is so because it's no SQL database, there's no keys. So we had a key field. It was keyed off a GUID, and then they needed to make some changes. So they changed that effectively that structure. So it changed the grain of the data. So they retyped the GUID and changed the grain of it. So now it became parent-child key, right? And for them, it was fast. It was like, we need to make this change for the app. This is the best way of doing it. Bang, bang, bang. The whole, NoSQL database re-optimized itself. And now we're starting to get this feed with a key that is no longer single grain, but is a multi-grain key. And again, it does bad things to you, right? So it's like going back to something going, look, it's fine. You need to do that. You need to be agile and flexible and able to do that. But here's the downstream impact. We need to work on those ones together, and we can't automate that yet. So a lot of it's that conversation, that language, and helping people understand what we do and why what they do affects it. And then what can we do to reduce the blast radius of that change? Because that change needs to happen, right? We can't say, you can't add a column to your database. Ridiculous. You think you own your database, like we used to do.
Well, and that's why I think where value stream mapping is incredibly helpful. And I wish more companies would use this and more teams, because if you focus on sort of the end product of what a customer wants, and the external customer, the end customer, not some internal facing one, but then you start seeing kind of cross-sectionally, if you can follow how data moves, information moves, which is one of the things in value stream mapping you do. You get all the stakeholders, software engineers, data people, business, et cetera, and I think that accomplishes a lot of that shared vocabulary you're talking about, as well as has empathy for, sort of the end product at the end of the day. It's not like, again, I don't think, anyone's doing this stuff maliciously. It's just, you're incentivized to focus on what you're, paid to focus on. And if I'm not paid to, care about the data team's needs, then why would I, right? Like I have enough things to do right now, and that's perfectly understandable. Right. So
they got product owners up their bums, right? Going build more faster, and they're really good at iterating their way of work to reduce some of that manual stuff. So here's an interesting question for you then, because I just think about it. So there's lots of patterns in the software engineering world, and there's lots of patterns in the agile world, and lots of patterns in the product world that we can adopt, right? So, for example, personas, right? We should be using personas for our users for data, right? And understand the different types of users we have. Oh, there's machine learning engineer, right? They want the data they want raw data. Again, you look at the medallion architecture from Databricks, which is just a copy of a 3-tier architecture we had 20 years ago, but good that it's getting regenerated, right? That raw, combined or cleaned and consumable, right? A standard architecture. And we used to have this argument 20 years ago, which is nobody's allowed in raw. You can't trust them in there. And then you get back there was a data miner, and they're like, but I need the raw data to do behavioral modeling because I need some flags to say this person bought 5 products versus this person bought 10 and what they bought. And so we see those kind of data problems turn up. And so, given we've lost the art of data modeling because we're not teaching it to the new generation that are self-serving themselves, and given the software engineers are now using NoSQL databases that don't need a relational data model, what are you seeing? Are you seeing, that when somebody's designing an application as a software engineer, are they still using a Miro board, whiteboard, whatever, right, just to draw out a structure of the data, a conceptual model, or are they just ripping in and writing code and refactoring it as they go now?
I think even if they do the whiteboarding up front, which is, I would say it's maybe 50-50 when they're starting out, it, you know, it, it's so easy to add new fields in after the fact that you're just like, okay, so do I need to have a formal committee meeting on this, or do I just add a new field, right? And so that, I mean, if you look at a lot of code, I mean, I was at a dev shop the other week, and somebody had Go on their they're just writing a Go app, and I mean, you just kind of tell like what was happening. I mean, it's just new field in the database, not a big deal, add it in, done, right? So I just think it's because it's easy, it's easy. So, and again, you just need to make the app work, and that's it. So even if there is like formal modeling done up front, I mean, but NoSQL makes it really difficult. I would say there's not like an ERD, for example, right, that works with a NoSQL database. I mean, Lord knows there's like a million different NoSQL databases too. So like, how do you approach it? But say with even nested data, maybe you'll draw like your parent, and then children and so forth. But it's it just ends up being a bunch of squiggly lines with a bunch of key value pairs, and that's about it. So it's the notion of modeling. If I'm looking at my table over there, I'm looking at Codd's book, right? Like that thing is all about just set theory and algebra. Like it's very formal, right? And then you might translate that into an ERD. I know Cod hated ERDs, but maybe that's a tool that you want to use to design your database. I just don't see a lot of people doing that these days, or at least as much. So
Yeah, so let's look at how the software engineers have refactored their practice, their way of working. Right,
yeah,
they've got some new technology that makes them faster, and then they've altered their practice to say there were some things we used to do that don't have as much value now, so we're not going to do them. Right? There's some consequences of that behavior, but we're not
yep,
going to model heavily up front because our rate of change, our ability to change, and the speed we can make that change, compared to the old days where we had a
fast,
spec, right, which took 6 months, and we have a design that was signed off by the architect, and somebody would go and test that the application we built, the data model in the application, actually matched the
mm-hmm.
spec, not their user outcome, and the product was changed. That it said customer is the king, right? It doesn't matter whether
Yep,
the spec matches what was built. It matters whether the value was delivered to the customer. And sometimes we
yeah.
get it wrong and we just iterate it. In the data world, what have we seen? I mean, I'm amazed that we now have a whole category of graphical ERD modeling tools turn up again.
Yep.
It's like, why? Like I'm keen, we should be data modeling, but we shouldn't be doing ERD diagrams as our technique for data modeling anymore. I mean, that's 20 years ago. And yes, they're prettier and easier to use than EA Sparks and whatever the hell those crap tools we used to use, right, for data modeling. But we haven't refactored that practice yet. Our brethrens and other domains have, and I'm intrigued, right, because we've seen massive change in the data space. But have we really? Have we seen a change in the core patterns or not?
That's a good question. I don't know that we have. I mean, we're still asking the same questions. I rant about this a lot on LinkedIn. It feels like we're just kind of in Groundhog Day with a lot of the same questions we ask, right? One of them is like, oh, what value do we add? And it's kind of like, well, if you have to ask that question, I highly doubt you're adding anything. So there's that. There's an inverse correlation between those. But as I tell data people too, if you kind of want to know where the field's going, I would say just look at software, and at least there's at least borrowing of a lot of ideas. I'm not saying it's a direct one-to-one mapping. Data is different, but data ops, data reliability engineering, and data observability. I mean, these are literally just software practices applied to data. And so, as far as modeling goes, though, I feel like maybe the equivalent to with analytics engineers is really maybe the DBT model and how they're doing it, which is one big table typically, right? So it's just if it's easier to do that, then that's what people are defaulting to. And
Oh, yeah. So I'm going to disagree with you there. So if we think
you
about
think
data
so?
value stream, so with the data value stream, I think one big table at the end, right? Consumable one big tables is what we should be going for. The technology can handle it now.
Mm-hmm.
But what we end up with if we do that is we, in the middle layer, right, and the designing of our data, is we end up with thousands of jobs and thousands of tables that have the same data. And there's no way
Mm-hmm.
of optimizing that as a user. I don't care about the technology. I'm as a user, which column holds customer? And that's a
Mm-hmm.
data design problem. So what I'm going to see, I think we're going to see, because most of our changes happen via technology, right? And I think we're going to see technology help us solve this problem and change our practices in one of two ways. If especially with ChatGPT now. So if we think about taking those 3,000 blocks of code, you're writing DBT, and having the machine create the model for us, and then rewrite the code to conform that model, then we now get design data. But we're designing as a chaos theory, right? Everybody's kind of just writing stuff, but the machine is actually coming up with a design as a recommendation and then Retro's fitting it. Or we get a semantic layer, which, in the old days, semantic layers were at the BI tool layer, right? Because that's where the value was. We've
Mm-hmm.
seen them start to be pushed back. But again, actually the semantic layer is the gluing of those 1,000 big tables to say, when you talk about active marketing customer, here's the thing you hit, and we find where that field is for you. You don't need to care, right? So that's where I think technology will change our practices.
It could. It could. I mean, I'll push back and say, like, as a longtime Looker user, for example, when I look at LookML code, there's some code I think that has discipline to it, and in the sense where there's no duplications. And in some cases, I've seen LookML where it's bananas. I don't quite understand what just happened there, where the whole point of LookML, which is a semantic layer to just attach to a BI tool like others you described, but it did get unwieldy. I was like, I don't know how you got into this mess. Or there's now, your LookML file is almost as big as all your DBT code, and that sort of defeats the whole purpose of it, right? So,
But that's due to a lack of practice, right? That's because what
it's
we're
like a
saying
practice.
is,
I'm not disagreeing with you on
yeah,
most of this. I mean, we're actually in violent agreement, I would say, on most of this stuff. It's like, because the same practices that happen with NoSQL, where it's just let it rip. The same thing's happening in analytics engineering. It's just like one big table isn't at fault, but it's like, 1,000 DBT models is more of a symptom of a lack of practice, because it's so easy just to make a model. It's like, screw it, I'll just do that. Like, why make it coherent? So
and so if we come back to data modeling, what's the problem? It's not easy to make a data model. So easy to create a piece of block of code that creates data that's valuable, right? It's so easy to create one big wide table that performs now and people can use. It's still bloody hard to design your data. And so that's the problem, right?
be
If we solve
intentional
that,
at it.
if we make it easy, right? If we make it where it's a no-brainer, it just happens and it's low effort, we do it. It's because it requires high cognition, a separate set of tools, a massive amount of experience and training, depending on the data you're looking at. Header detail, how do you model that? Party entity, how do you model that? Manager employee, how do you model that? Was it Shopify? You look at Shopify and you go, 15 tables, it's really easy. Yeah, but no, we've got an order. Order has a transaction has a return. A refund. Refund only turns up in the data when a refund exists. So you start getting the schema of the data you get given change, right? And one of our customers was, they had a bunch of products on their order. And then the payment, they use gift cards. The payment basically was allocated against the order. But what they needed was, they actually needed to understand, based on the different payment types, how much of each product line was credit card versus gift card. And so that was complex because Shopify doesn't do it for you, right? So you have to basically allocate the costs based on a simple algorithm. But again, there's complexity in what you think is it's just Shopify, right? Customer orders product, customer pays for order. And that's always my first question I always ask somebody when we go through some training is it customer pays for order or customer pays for product? Is it customer returns order customer returns product. That design, that business question infers your design more than anything else, more than the technology, star schema, data vault, whatever.
Yeah.
So, for me, it's still complex. It's still a high level of cognition. And until we find a way to remove that, most people won't model.
Yeah, and I guess the consequences of that are, as we were talking about earlier, it's trade-offs, right? So I mean, there is debt you incur by not modeling. And what that means is you just have I think, a lower understanding of your business, for one. I mean, at the highest level, data modeling is not necessarily meant to come up with a physical implementation of data in your database. It's meant to come up with an agreement on concepts and business
Yep.
rules and how data relates to that. So if you don't want to put in that work, and again, this is what I'm writing about. Like, I don't really care what you do with your time, but do understand that if you don't take this exercise seriously, the consequence is that you simply don't understand your own business and the data that you're reporting. And that's kind of the bottom
Uh,
line. So,
yeah. So I haven't thought
or
about this.
working with.
Yeah.
So,
I
yeah.
haven't thought about this before, but you've made me think about it. So I put it, actually, if I was going to answer it, I'll answer it this way. And this is not well formed because I'm basically just pulling it out my bum right now. But based on experience, right? If you don't design your data, you've got a $5 million problem.
Mm,
And the reason is there's two reasons an organization greenfields their data platform, right? And if you look at organizations like, if you think about our domain, the data work we do, let's look at it as our restaurant, right? We built a restaurant. It costs us $5 million. We run the restaurant for 3 to 5 years, and then we go, "Yeah, that didn't work." We burn it to the ground, and we go and build another restaurant in exactly the same place. Different ovens, different people, different patterns, maybe different recipes. We go from barbecue to Chinese.
yeah.
So there's two triggers, right? First trigger is technology. We see a technology wave happens. The technology we're already using works. It's got some problems. It has value, but we like shiny, right? So somebody comes in, they want to make a name for themselves. It's like, yeah, cloud data warehouses, and they are much better than what we had. But we're going to rebuild everything from scratch because of that. First trigger point. The second trigger point is mad person's knitting.
Mm,
Somebody comes in and goes, it's been 5 years, there's 3,000 blobs of code, whether it's Informatica code or DBT code or whatever the next shiny thing is, these 3,000 things, and it's chaos and we can't understand it and we can't find our data anymore. We need to rebuild it. And that second one, that $5 million bill, is because we didn't design the data up front. Lightly
mm.
design the data up front. Right. So there you go. That's my takeaway. If you're not
I
willing to
like it.
change your technology every 5 years, design your data and save your $5 million.
Or to send it to Shane. One of the two.
Look, I only need 10%. But you come
I
from
live
a
in Utah.
consulting,
We do that a lot.
yeah,
So,
you come from a consulting background, right? It,
yeah, yeah. I've done a bit of that.
yeah,
So,
and so have I. And you kind of, what I say to organizations I work with now is when you engage with an external party, with a vendor, first question you should ask them is what's their business model? How do they make money?
yeah.
And in the past, as consultants, we made money by doing data design because we got paid to spend 6 months in a room doing it. And it was a hard
Right.
task. And there were very few of us that could do it. And therefore, it was expensive and we got paid lots. Now we don't do it. We have teams of people that write lots of code, and we know in 5 years' time, because we've seen it before, we know in 5 years' time we'll be back, or somebody else will be, and we'll pick up the one
Yeah.
that they did. So for me, the incentive for consulting companies to optimize the way a customer works is not there, right? Their business model is around bums on seats and hourly rate. But I don't know about you. Maybe that's just us end of the world New Zealand thing. I don't think it is,
I
but
don't
who
know.
knows?
I mean, my business model at Turner was always different, where it was, flat rate, fixed price, fixed scope. So I had every reason in the world to kind of like finish quick and get out. So, um, and the other incentive I had too, I mean, when Matt and I had started the company, it was just the two of us, and now it's the two of us again. we never really liked doing services, kind of a hands on keyboard, button chair kind of work. It just, I don't know, I felt like I had a job, and if I wanted that, I would choose not to work for myself and go get a job. So it's a lot easier that way. But the approach that we would take actually is coaching, and I think showing data teams how to do what we do, and really sitting alongside them, pair programming, and just I think helping them level up their skills. And people love this because they feel like they're empowered, they feel like they're in the driver's seat. And there's always a constant tension. If you're a services company and you come into a client, um, most of the time they're probably going to hate your guts on some level, because you're a higher paid version of what they're doing. They feel threatened by you. And I felt like the jujitsu move really was, well, what if we just helped you become a better version of what you're doing, and we have no incentive to stick around longer than we have to. So, like I said, people tend to like that approach. That's how we made money. It was just, I would say, sort of the almost doing an anti-consultant type of thing in a way, but it worked for us. I can't say that it's a good idea for a lot of people. It's probably a really terrible idea. But
Look, I think it's a good idea for people, and it's a good idea for customers. Effectively, it's a coaching model, the same one that
yeah,
I do when I need to do a side hustle. The
right,
problem is that it's not a good model for a consulting organization that has 50 people that can code and
right,
need to be off the bench, right? So go back to the business model, right? If you ask your consulting friends, partners, how do they make money, and they go, well, we coach your team to be as good as us, and then we exit until you need us to coach them something new. That's the partner you want, right? If they go,
right,
we've got the experts in the market, it's like, and how do you charge for them? Hourly rate,
right.
daily rate, even fixed price, right? Because fixed price is still time and effort. It's still effort based.
Yeah,
Then run and find somebody, that's going to coach you. Out of interest,
yeah.
did you coach them on data modeling?
We would, yeah, or I
Yeah,
would,
yeah,
when necessary. I feel like it's one of those things where it's like, I don't know, showing people how to floss their teeth or something. Some people want to learn this, and others are like, I have no interest in learning this stuff at all. Just
yeah,
show me how to use Snowflake, right? So, but I think implicitly what I've learned is, you want to sell things through the action and the outcome, not really, uh, So if we're going to talk about data modeling, then it's like, well, let's think about your business. Let's think about the data we're going to put into Snowflake, for example, right? Like, so what are you trying to accomplish? What are the reports you want to generate, really, and work from there, work on the outputs. If you try and approach it from data modeling, people think you're just giving them a lot of extra work to do, I think.
yeah,
And
and
so
so
that's
yeah.
that's how you pitch it.
So that's an interesting one. So again, I've got a slide I do when I coach teams, and I talk about these three ways you can design your data, model your data, right? So source specific, we model off the source, so we go spend some time looking at it. Output specific, so we look at what the user wants on their report, their dashboard, or the thing. And business process specific. And
Hmm,
over the years, I've become very opinionated. We model based on business process, and then we map it to our source systems and what the user's after.
that makes a lot of sense.
Yeah, so who does what? So I know we're almost out of time. So I'm going to flip the thing. One question for you. So given you're
Okay.
doing all this research on data modeling for your book, you know, what is the best one data modeling technique you should use, and why is it Data Vault?
I think it's not a data modeling technique at all. I'm more convinced than ever. I think that actually taking a step back and doing value stream mapping and process mapping is probably the best modeling technique you can learn. It just helps you understand the flow of data and money through your organization, right? And I think it helps you unlock where all the bottlenecks are. If you can do that, you have a superpower. And I would say, like, the world's your oyster in terms of whatever data modeling technique you want to apply.
Yeah.
If you don't understand how things flow, as Charlie Munger says, you're sort of a one-legged man in an ass-kicking contest. You're just like, you're at a pretty serious handicap. So I don't know. What about you? What would be the one
Uh,
technique to rule them all?
I'm a Data Vault bigot only because it's the best model. It's the best. And Data Vault 1.0, right? So I talk about Data Vault modeling, not Data Vault 2 and all the other crap that goes supposedly with it. So for me, Data Vault at the moment, because it's the best modeling, most flexible modeling technique I can find. And it's got a bunch of problems, and I hope somebody comes up with something better. Um, but I go back to your point there about value streams. So, if you've got a team, get them to map out their process and how they're working
Yeah.
when the team touches data, highly valuable. And then the next thing you want to do is you want to map out your core business processes, right, as an organization, and use the term who does what, right? And you're going to see,
Yep.
if we take an e-com one, customer orders product, yeah, or customer places order, customer pays for order. Store ships product or store ships order. You're going to see this hierarchy of business processes, and that's your data model. That's your shared language. Whether you
Yeah.
physicalize it in dimensional or volt or activity, who cares? And as soon as you start asking who does what, and you map it out as a graph, as links and nodes on a screen, on a whiteboard, Miro, or whatever, you're going to find the complexity. Right? You're going to go to that problem
Yep.
of, does a customer return the order or do they return a product? Because they're two different design decisions. And value stream, who does what, there's your conceptual model,
That's
80% of it,
awesome.
right? And your big areas of concern, they stand out
It's
like
kind of what you need. That's all you need,
multiples, right?
man.
Yeah.
Really. If you were to ask me like my favorite data modeling technique, I would say like another answer is, if you were to do, if you were to look at UFC, like, well, what's your favorite, what's the best mix, what's the best martial art, or what's the best move that you could use in a fight, right? I think it completely depends on where you are and what's happening to you. There's no shortage of modeling techniques out there. I think that's, and some I think that are TBD, like in streaming data and machine learning, that's still, I think, kind of up in the air if there's any canonical way of doing stuff. But
Oh, I love
I would
that.
say, you need to learn what works. I mean, and be able to apply it. So,
I love that. I love. I've never thought about it. Mixed martial arts. That's a great way. That should be the theme of your book, right? The mixed martial
oh, it
arts of
is. It's
data
actually a
modeling.
big theme of it. Yeah, I mean, totally nerd out on it. I used to do it, but it was like the thing you quickly realize is, if you're like the kung fu master saying, oh yeah, kung fu is like the best martial art, like that guy's gonna get his ass whooped pretty hard, very quickly, in spectacular fashion. And that's how I feel like a lot of people approach data modeling these days, where it's like the one true technique. And I'm like, I don't think that there is. And if you try and do that, especially in a cross-sectional way, across the data life cycle, it's the same thing. Like, again, going into a fight, only being a boxer, like you're going to get taken down and manhandled. So that's what will happen. So
Yeah. Yeah,
yeah,
I'm with you, right? There's a bunch of patterns, and you get good at them, and you always go towards the one that you know the most, right? The one you're the most comfortable with, because that's when you're in fight or flight. That's what you refer back to, right? So wrestlers always
yeah,
take you to the mat, boxers always hit you in the face, right?
that's how
When
it
they when
is.
when they're in trouble, but you still need that toolkit, or you're going to get your ass whomped. So yeah, there we
Yeah.
go. That's what we need: mixed martial arts of data modeling. Yeah.
Well, awesome, man. For people who want to learn more about you, how can they do that?
LinkedIn's probably the best way to do it. My handle
Cool.
under there is Shagility. A little bit on Twitter, but I tend to be rant ready on there at the
Agility.
moment.
Okay. I always wondered what that was. I thought it was going to be shagility or something. And
Uh, yeah,
but-
so it's Shane and agility, but it's also a little bit of Austin Powers, baby.
the
Shagility.
international data nerd of mystery. That's funny. Um,
Yeah.
and you got a podcast too, right?
Yes, I do too. So I do the Agile Data podcast. And so what that's about is where I've found somebody that has a set of patterns that they can actually describe without pictures. I get them on the podcast. And that's actually really hard, right? It's really hard to get somebody who goes, here's a pattern that you can implement, and here's the context of when you should and shouldn't implement it. So that's that one. And
Right.
then I co-host one called the No Nonsense Agile podcast, where we have Agile and product people come on. And for me, I've kind of it's really interesting. It's almost like free training. I mean, we get
That's cool.
experts on who know their stuff, and then they spend an hour talking to us, and I get to ask questions to kind of understand how continuous discovery works or those kind of things. And then I'm like, cool, I learned something new, and how do I apply that to data, and how do we apply that to our startup? So I don't think we've ever told them, and hopefully they don't listen to your podcast, but yeah, I just treat it as a 3 hours training. It's awesome.
I always do the same thing with my podcast too. Like I feel like I learn a ton, even today I
Yeah.
feel like I learned a ton. I took a lot of notes on the side, and but yeah, I mean, it feels like podcasting is sort of this cheat code where you can, talk to really smart people and learn a lot if you're paying attention. And I think it's awesome. So,
Yeah, and because my co-host on that one's Australian, he's really really grumpy, and
oh,
so
perfect.
we were going to call it the no bullshit podcast, but we got flagged.
You get flagged
So,
for that.
yeah, so what Murray's really good at is really just getting down to those examples, right? Because what we found was there were a lot of fluff merchants, and there is in data as well, right? There's a little, like you said,
Yeah, there's a lot.
us talking to ourselves a bit, and so getting back to that meat and potatoes, right? Which writing a book, that's what you've got to get to, right? You can't write a book of fluff. You've got to put some meat and potatoes in there. So
It would really suck. Yeah. So you'd like Salt Lake City too. I mean, not too far from here is where the Agile Manifesto was penned, actually, up at Snowbird. What was it, 22 years ago now, or something like that? So yeah, it's,
yeah, I've got to go to Austin next, apparently, because all roads lead to Austin. But yeah, definitely, we'll be over in the US probably sometime next year. So we'll do a bit of a tiki tour around and maybe come and visit.
Yeah, please do. Yeah. You got a place. So well, awesome. Well, great chatting with you, and I guess I'll see you back on Slack. So, yeah, fun conversation. I learned a lot on this one. So, yeah.
Yeah.
Awesome. Well, we'll talk to you soon, man. So take
Excellent.
care.
Thanks for having me.
All right.